Okay, hi guys. So in this lecture, we'll be starting off with seeing some of the reactions of aldehyde ketone. Okay. So before that, let's look at this reaction in which we have aniline substituted with a CS3 group. Okay. So we have CS3 group here, NH2 group here, and what happens when this compound reacts with this compound? So we'll get something like NH here, single bond and double bond N, where this nitrogen atom attacks this nitrogen atom. Okay, and as a result it will get back its bond electrons from the nitrogen atom, making it a neutral charged nitrogen atom plus H plus. Next, what will happen is, in presence of OH minus, what will happen? This OH minus will take this H this H plus from the nitrogen atom, and at the same time this the negative charge on the it will result in the negative charge on the nitrogen atom. As a result, it will form a double bond with this nitrogen atom, and as a result, or in the consequence, this nitrogen atom will withdraw its bond pair from this nitrogen atom and will attack on the H plus released in the previous step. So I am showing all the step in this reaction as only. So we'll have something like N double bond and NH pH. Okay, so this was just a reaction which we just had a practice with. So nothing to do with the reaction of aldehyde or the topic which we are going to discuss now. So we are going to discuss reaction of aldehydes and ketone in this lecture. Okay, so what we'll be having first a reaction with cyanohydrin. Okay, and we have this with KCN in presence of acidic medium. Okay, so what we'll be having is, you can also have something like HCN or HCN in presence of ETO minus. Okay, so we'll have something like RCH OH CN here. Okay, and this is known as cyanohydrin. Okay, and the RDS for this step or for this reaction is obviously attack of CN over this partially positive carbon atom and the formation of O negative here. Okay, then obviously in acidic medium we get this product. Okay, so let's discuss some of the notes on this. So cyanohydrin formation is an example of nucleophilic addition reaction. Cyanohydrin formation is an example of nucleophilic addition reaction. Okay, second point is that attack of CN is the RDS. Attack of CN minus rather is the RDS. Third point is rate is proportional to the concentration of cyanide and aldehyde. Rate of the reaction is proportional to the concentration of cyanide and aldehyde. Okay, so in the question below, or we have to identify the unknowns in the reaction. Okay, so we have first question as we have pH CO double bond O CS3 and we are reacting it with HCN. So we'll be getting product A plus B. So what are products A and B? So A would be obviously a cyanohydrine, okay, with OH, CH3 and CN here, and B would be, what would be B? B would be again this compound is a chiral center, okay. So CN can either attack from the top side or from the bottom side. So depending upon that, we'll be getting the B product, okay. Just have to make the, if it's R, you have to make the S configuration, and if it's R, you have to make the R configuration, okay. Second compound is acetate, rather it is called ethanol, okay, which is reacting with KCN in presence of H plus. We are getting product A, and then having hydrolysis in acidic medium, we are getting product B. Then what are A and B? So A and B would be, A would be obviously a cyanohydrine, okay, and B product would be something like, what will hydrolysis of nitrile give? So we'll get something like, this would be the hydrolysis product of cyanohydrine, okay. So this is also a famous compound called lactic acid, okay. Let's look at another example. We have a ketone group, okay, and first we are reacting with HCN, we get product A. Then on reacting with LiAlH4, we get product B. Then on reacting with NaNO2 in HCl, we get product something like this, okay. So let's say it's also a mystery. You have to determine this product as well, okay. So what would be the product A? Product A would be nothing but a cyanohydrine, okay. We'll be having something like OH and CN here. What happens when we react it with LiAlH4? So the product B would be, LiAlH4 is a strong reducing agent, so we'll be getting CH2NH2, okay. And when CH2NH2 reacts with NaNO2 in presence of HCl, what will happen is diazotization will occur, or will the diazotization occur? Yes, diazotization will occur, and as a result we'll be getting nitrogen gas released, and then we'll be getting something like OH CH2 positive charge here, okay. Then what will happen is, on this positive charge, the ring expansion will happen from 5 member to 6 member ring, and this carbon would be getting a positive charge here, okay. Why would this be stable? Because of formation of our very stable IIT cation, okay. Then what will happen is, double bond formation will take place between this carbon atom and this oxygen atom. As a result, we'll be getting something like this compound. So this would be product C, okay. So with this we come to an end of this lecture. In the next lecture we'll be seeing reaction of aldehydes and ketones with NH2Z, okay. So till then, good luck and goodbye.